So hello, everybody. Today, what I hope to show you is some practical things that you could perhaps use when you're building your own applications with Pinecone and potentially Vercel. I'm going to build on stuff that we've seen throughout the day today. So earlier today, Jared showed you how to build a simple chat application that talks to Shopify and kind of retrieves information from there. What I'm going to do today is a little bit different. I'm going to try and attempt to show the process of going from a chatbot that doesn't know anything about the world to a chatbot that is somehow grounded in information that comes from the web. So this is going to be like a fully JavaScript, TypeScript demo. So I'm sorry to all of you Python people, but I, like many others, believe that the future really is with TypeScript. And I hope that by the end of this talk, you'll see why I believe that. So let's get started. So the very beginning of this, we have a very standard application, Next.js application. There's really nothing special going on. As you can see, it just has a header and some body. And we'll start by creating the front end of the chatbot, which is incredibly simple, as you saw Jared do today. Thanks to the very helpful hooks that we get from the AI package. So we basically have all of these already handled for us. We have like a lot of stuff here around tailwind styling and whatnot, but really all you have here is a box where you can send some messages. Make this a little bit bigger, and eventually we'll see messages in here. Okay, so to add the back end to this chat to this front end, also incredibly simple. There's not many lines of code that are required. We create another route under chat. These are like kind of like magic or default settings for the use chat hook, but of course you can change that using the configuration. And all that we have here is some OpenAI configuration, as well as some initial prompt, and we're choosing what model to use for the application. And then we pass into this prompt, into the model, we pass in the prompt, as well as the messages that come in from the user. So in this particular example, I chose not to include the messages coming in back from the model back to the model itself. It just ended up adding a lot of noise. So I'm basically just filtering these messages by role. And now you can see that if we say, hi, OpenAI, it should hopefully say something back. Right, so now it's saying something back to us and everything is great. So we built a bot, very basic bot with not a lot of difficulty. So what do we have to do to make this whole thing work with Pinecone? And for that matter, to actually use information that is coming outside of the bot's model itself. So we'll start by initializing our Pinecone client, and that is, let me see, that is down here. Initialization is incredibly simple, just passing in keys, nothing special. Okay. The next step is I'm building this function here that is going to allow me to just like grab the matches based on the embeddings that I'm going to pass in to Pinecone. So all that this function is just like a convenience function that allows me to pass in the embeddings, the top K, and the namespace potentially, and then just get back just the matches without anything else. Okay. So again, nothing special going on so far. We just have a couple of initialization functions and a wrapper function around Pinecone to make our lives easier down the road. The next thing that we have to do is start dealing with embeddings. And again, thanks to the work that folks at OpenAI and Vercel have done. We have OpenAI Edge. So now our OpenAI functions can run on Edge functions, which is incredibly helpful. And we basically, to create the embeddings for our model, all that we have to do is tell the model tell the API which model we want to use. In this case, it's text embedding 802, and pass in our input. Now, it's important to remember that we're actually using two models here, and they have two completely separate goals. The first model that we're using is the GPT 3.5 or GPT 4 in some cases, and the role of that model is to facilitate the chat functionality, and it has nothing to do with getting the embeddings. In fact, the embeddings that we're getting have much lower dimensionality, and it is quite sufficient for most of the purposes for retrieval. And you'll see that moving forward. That there's no need to actually have the same model for your chat interface and for your embeddings. Okay. So now that we have a way to actually get embeddings for things, let's look at how we would essentially get the context, some context, to our chatbot given some input. Okay? So I've created this function called getContext, and the getContext function gets a message. This is just a string, some namespace, which is the namespace that we're targeting, and we're not going to be using that in this demo, but it will be used in our demo when it's published. We have some minimal score of similarity that we're forcing on this context retrieval, right? So we can decide that we want this to be incredibly accurate and only include results that pass some threshold. And we have two forms that we could get this can get back this context. We could either get just the text, or we can get all of the documents back as they are stored in Pinecone. So in Pinecone, if any of you already used it, you basically have, other than the embeddings themselves that are stored in Pinecone, you have metadata that's associated with every embedding. And so we can choose whether or not we want to retrieve. This function basically allows us to very quickly slurp out all the text from the results, so that we just have context that's ready to just go and get injected into our model, into our LLM as part of the prompt, or we can just get back the set of documents that have been hit as the result of that context. And you will see how that comes into play a little bit later when we interact with interact with a chatbot. Okay. Next up, we're just adding in this route, right, where we have our chat. We're now introducing this get context, right? So this get context function that has most of these parameters set as default. So like the min score and top kits, etc., are all set as default. I'm only passing into it the last message, right? The content of the last message that I get back from the chatbot, right? So the user types in a message, I'm passing in that message, and I get the context, meaning the most relevant, semantically relevant pieces of content from the vector database, and those are going to be injected into the prompt. Okay, so next I have to actually update the prompt. So now, let's actually go back a little bit. So before I updated the prompt, the prompt didn't say a lot, right? It basically told the AI what it is. It's telling it that it's a brand new, powerful, human-like artificial intelligence. It tells it about its traits. It's telling about how well-behaved it is. Things that are kind of like setting the scene for how we want the chatbot to behave, but nothing particular about the context. And now we're going to add some information about the context. So what I've done here, and I've experimented with different ways of prompt engineering this, and I would say this, like I think in my personal opinion, prompt engineering is still very much kind of black magic. There are things that work well, there are things that work less well. It really depends on the situation. In my opinion, having these very clear blocks with context kind of helps, because it lets the LLM know exactly what we're targeting. And then after I've set this context, I'm basically injecting this context that I got previously, and I'm injecting it right here in the middle of this block, right? So all of the text that was retrieved from the similar documents to whatever the message was that the user sent to the bot are going to be injected here. And I'm going to tell the bot very specifically the following: AI assistant will take into account any context block that is provided in a conversation. So if I have multiple context blocks in the conversation, those will be taken into account, because these get concatenated. If the context does not provide an answer to your question, the AI assistant will say, "I'm sorry, but I don't know how to answer that question." So that's another important thing to do. We're kind of guiding the AI to try and not hallucinate, right? And sort of really, really stick to the script and only answer according to whatever is contained in the context. It goes on and on. There's like a little bit more kind of like direction to like not apologize for not knowing things, because it's doing that, it's kind of annoying. But that's basically the message here. We're telling a bot, just look at the context. Don't look at anything else, and make your answers based on that context. Okay, so now we have a bot. It knows how to retrieve some context from a vector database, but there's nothing in the vector database. So like, what is going to be there that it's going to retrieve? So we're going to make a crawler. And this crawler is very simple. It does a couple of things that are useful. One is that it knows how to fetch a URL. It in fact knows how to go and fetch more URLs if it can find links inside of one URL. It can go and keep spidering in, but that doesn't really matter right now. We're just going to fetch one page. The second thing it can do is it can turn the HTML into Markdown. And that comes in, again, very useful. And I found this sort of the hard way when we're going to think about chunking our data. And we're going to talk about that a little bit later. Okay, so great, we have a crawler. Next, we're going to want to use this crawler to actually take it and do something with it. So the seed function is going to take a URL, some limit, so we don't keep running around and fetching more and more URLs. It's going to take an index name to know where to actually put this stuff. And here's what it's going to do. It's going to take a bunch of options as well, right? And these options are going to be the following. It's going to know which splitting method it's going to use. So we're going to either use what's called recursive character text splitting, or we're going to use markdown text splitter, right? Both of which are methods that you can find in LangChain. I unabashedly just took these two methods and just like ripped them out into like a small utility library that just includes these two functions, because I don't need the whole of LangChain. I just need these two things. And we also define the chunk size, if that's relevant, and the chunk overlap, right? So these two parameters are, again, fall into the world of sort of voodoo-ish, in the sense that there's no hard and fast rule that will tell you, hey, always use 256 tokens for your chunk, or always use 512 tokens for your chunk, or 10 or 1,024, et cetera, et cetera. People have varying opinions about what the magic number is. I'm strongly of the opinion that there is no magic number. It really depends on your actual content and what you're trying to do. But there are other tricks that you can apply, and we'll talk about that in a second, that to me make a lot more sense than just trying to guess a number. And The other form of doing chunking or document splitting is Markdown, using a Markdown text splitter. And basically what Markdown text splitter does is it looks at a Markdown file, and depending on its structure, it defines what the chunks are going to be. So we're no longer trying to guesstimate like the size of the chunk. We're actually looking at the size. We're actually looking at the structure of your document and looking for paragraphs. We're looking for headers. We're looking for code segments and other types of Markdown settings that will tell us how best to chunk the document. And that makes to me a lot more sense, because it kind of like assures me that the segments that have been divided by potentially the author of that document, right, are going to be internally kind of cohesive, right, in the sense of what's semantically related to what, right? So I have one chunk, it will have semantically related stuff within it, and that portion could be embedded as a unit, right? And when I search for something, I would search for the things that fall within that unit. Okay, so this function will basically create us a Pinecone client. It will get these options. It will initialize that crawler. It will fetch, and here you can see I just put the magic number 1 to say like we're only going to go to depth of 1. We're going to grab a bunch of pages. We're going to choose the splitter based on whatever option we get from the front end. Now we have our documents. And I'm going to gloss over this. Is going to be one of my only hand-wavy things that I'm going to do here. And then basically create an index if it doesn't exist already. And then I will basically call this embedding function, which is down here. And all that this function does, it basically takes the document, its content, and it creates an embedding out of it. And then it returns me a vector, which is an object that is ready to be saved and upserted into Pinecone. So this whole function, this seed function, will basically, if we just summarize, take a page, crawl the page, embed the page, chunk the page, embed the page, and move on, right? Okay. We'll add that to our route. So now we have a crawl route. We have some endpoint that like our UI can go and say, here's a URL. Please go crawl and seed that URL. And that way, that URL is going to be embedded. Everything in it is going to be chunked, embedded, and saved in Pinecone. Sweet. Okay, so now we're basically done with building our backend. Right? Our backend is sort of ready to jam with everything that we're going to throw at it. It knows how to embed documents. It knows how to seed documents and save them in Pinecone. It knows how to chunk them, of course, which is a crucial part. And it knows how to chat. So very quickly here, we're going to start creating the context panel. So on the right side here, this is where we're going to start plopping in some components. So what we're going to have are basically 3 buttons. These 3 buttons are going to represent 3 URLs that I selected beforehand, and we're just going to crawl them. And then eventually, we're going to see the contents of those URLs as chunks within this document, within this context panel. And ideally, when we send a message to the bot and it responds based on the context that we've retrieved, we'll also be able to know which portions of those documents, of those chunks, is actually relevant to the response that we just got. Okay, so let's go through that. So here I'm just adding these 3 URLs. These are just kind of arbitrarily chosen. And the reason why I chose these documents and not others is because they're very likely to not be known to the model, in the sense that they're time sensitive, and like they have content in them that happened way past 2021, and there's probably no way that the model knows about them, right? So it would probably be able to answer generally about all of them, but not about the specifics, right, that exist within those documents. Okay, so now we have these documents. We're adding some buttons. So now we have these 3 buttons here. When we press on these buttons, we're going to call that crawl, and that crawl is going to call that seed, and that seed is going to call a crawl, an embed, and save those in chunk and embed, sorry, and then save those embeddings in Pinecone. Sweet. This component is a card component. It's basically how we're going to show our chunks. This is another component that basically shows our 2 chunking methods. So we'll be able to either use our recursive text splitting and decide what chunk size it is and what the overlap of each chunk is going to have with other chunks, or we could just choose markdown splitting, to kind of simplify things. Okay. Now we're wiring together the crawl document call. So in here, changes in right here. So in this call, as you can see, I'm just grabbing like I'm grabbing the information that comes from the state of the application, right? So like the application is wired in such a way that whenever these components change, their state value changes. And so when I click on each one of these documents, it's going to make this API call and then pass these options along, and then we'll get back a set of documents. When the documents are retrieved, we're going to call set cards. Set cards is basically going to populate the list of cards that lives right here, right here. So here we have our list of cards, and that's going to be populated there. Okay, we're going to attach that to the button. Cool. So now we have like this on click, this crawl document is connected. Let's just see if this works. Cool. So not a lot of CSS going on there, but like this is kind of what we're expecting. This is the content of this page in markdown form. So I'm rendering the markdown back at us. And I can start asking it questions. I'm not going to do it just yet because I want to add the finishing touches of making sure that when I'm asking it a question, it's actually going to retrieve the context so that I know which of these chunks actually is relevant. Okay, let's see how we're doing on time. Maybe 5 more minutes. Yeah, we're almost done. So this is the context endpoint. So I'm basically doing this in 2 separate calls. One call is calling the chat endpoint, and the chat endpoint basically goes and calls get context and feeds the context back into the prompt, et cetera, et cetera. And then separately, I'm doing another call to get context that just gives me back all of the metadata regarding the documents and the chunks that have been relevant in that specific query. Right, so essentially I'm getting the same subset of chunks, but one time I'm getting it in the form of text that goes into the context, and one time I'm getting it in the set in a form factor of the entire metadata with the IDs, so that I can then highlight the specific chunks and in those cards, so that I know what comes from what. Okay. And let's just go to the very end, because this is kind of it. Okay. So let's just start with doing some tests. So I'm going to clear all of my indices, and then I'm going to click on this, and it's going to, again, go through the process of fetching the pages, chunking the pages, and embedding the pages and saving them in Pinecone. As you saw, all of this took very little time. Granted, this is not a very long page, but it's still pretty cool to see that it's pretty snappy. And we can start asking a question. For example, tell me about solar power in India versus China. And it's going to start answering me. And ideally, everything works correctly. Nope. Have we failed here? We might have failed here. Oh, demigods. Let's try this again. Well, it did not work. Oh, it did work. There we go. Thank God. Okay, so as you can see, the answer that it gave me here is China and India are two of the most popular countries in the world, and you have significant geopolitical and economic influences, blah, 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 blah. The content here is not surprisingly about solar power growth, right? So it didn't just give, even though my question was completely kind of like generic, China versus India, right? Like I didn't tell it to tell me about solar. It started talking about solar. Not only did it do that, it also gave me some particular numbers, like this 82% here that I see that is actually coming from this particular chunk that's highlighted here. So you can see that I have a bunch of chunks, none of them are highlighted. These four are highlighted, and that tells me that the response came particularly from these chunks, right? And you can see here I have this unique identifier. This is basically the way I do this is when I get back the documents from the database, I'm getting back a list of IDs, right? And the same IDs that are being used in the response, right? The same IDs get back in the context. And so I can highlight them, right? So when I get back all of the chunks back from the seeding process, that's what basically you see here. So like when I complete this crawl process, I get back all of the chunks that I've created with their IDs. And then when I do get context, I get the subset of all of these specific chunks that were actually relevant, and those are the ones that are being highlighted. And that's all I have for today. If you have any questions, please let me know.